Good morning, class. We are looking at Chapter 3, Derivatives, Section 3.4, the product and quotient rules. And we covered derivatives and rates of change, derivatives as a function, basic differentiation formulas, and now the product and quotient rules. And this is the synopsis of the two and a shorthand notation. We will go over that with more details. F G prime is F prime G plus G prime, F over G prime is F prime G minus G prime, F over G squared, shorthand notation. Reminding you again of what we have seen, given y equals f of x and a point A comma f of A, when you connect the two, the line PQ is a secant line, and we can calculate the slope rise over run. For example, f of x minus f of A over x minus A here. With this one, this is A, and this distance, we call it H, becomes f of A plus H minus f of A over H. If the name of this point becomes B instead of X, and this pair is B f of A, it's f of B minus f of A over B minus A. All of them are just a good old rise over run. And that's not a big deal. However, how do you find the equation of a tangent line when you have only one point and you need to calculate the slope? Well, we move the Q and get closer to P, and the tangent line is the limiting position of a secant line PQ as Q approaches P. Therefore, we get the slope of a tangent line, and finding the limit for this one, okay, and letting x go to a, so limit of f of x minus f of a over x minus a as x approaches a, or with this one, we take the limit of f of a plus h minus f of a over h, and we let h go to 0 this distance. And we call it f prime of a. These are various forms of lines. If we use the point slope at the pair a comma f of a, it gives rise to the equation of a tangent line y minus f of a equals f prime of ax minus a. You don't have to memorize it, stick with the point slope. If we generalize this and say it's x f of x here, and this distance is h or delta x, then we have the differentiation formula f prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. So this represents the slope of a tangent line at A. This is the derivative function, and it becomes the slope of a tangent line at a specific point, for example, A, when you fix the value of x at that point or replace it with that number. So the product and quotient rule, I remind you of the definition. dy dx is a limit of delta y over delta x as dx approaches 0, or delta x for that matter. This is the Leibniz's notation. F prime of x is the limit of f of x plus h minus f of x over h as h approaches 0. It's a good old definition. And the derivative of x is 1. The constant multiple says if you're taking the derivative of c times f of x, take the c out, make it a coefficient. And the sum and difference rules, they say the derivative of the sum is the sum of the derivatives. The derivative of the difference is the difference of the derivatives. And I gave you those lists. The derivative of constant is 0. The derivative of x to the power of n is n x to the power of n minus 1. That is the power rule, and we use often. And with that being the case, the derivative of kx becomes k. K is a number, is a constant. The derivative of e to the power of x is itself. Sine is cosine. Cosine is negative sine. The derivative of tan x is secant squared. The derivative of cotangent is minus cosecant squared. The derivative of secant is secant x tan x, and cosecant is minus cosecant x cotangent x. We will look at those with more details. Now, the product and a quotient rule, the derivative of f of x times g of x is f prime of x g of x plus g prime of x f of x. Shorthand notation, f prime g plus g prime. The derivative of f of x over g of x, which is called the quotient rule, f prime of x g of x minus g prime of x f of x over g of x squared, or shorthand notation, f prime g minus g prime f over g squared. What I want to add is that for those who have seen the product and quotient rules, the order by which you have seen it may have been different. For example, this may have been f g prime plus g f prime. And the reason I'm going with this notation, this order, because it really makes no difference for the product rule. However, for the quotient rule, it makes it easier to memorize because I use the same thing and I change it to a negative. So those of you who have learned it already and you have memorized it, stick with that. If you haven't, this would be a faster and easier way, okay? This would be a faster and easier way to put it. So now as far as the product rule is concerned, by analogy with the sum and difference rules, one might be tempted to guess that the derivative of a product is the product of the derivatives. That's not the case, and I have the proof of that at the end of the PowerPoint if anybody is interested. For example, we can see, however, that this case is wrong by looking at a particular example. Let f of x be x, g of x be x squared. And by the PowerPoint, the derivative of this guy is 1, this guy is 2x. If you multiply these two, you get x cubed, and you know the derivative of x cubed is 3x squared, which we call it fg prime. Now, if you look at f prime g prime, that means multiply 1 and 2x, you get 2x, which is clearly not the answer. Therefore, fg prime, which is 3x squared, is not equal to f prime g prime, which is 2x. However, this is the notation you probably have learned. D dx of f of x gx is f of x d dx of g of x plus g of x d dx of f of x. And the shorthand notation I use is f prime g plus g prime f. It's a shorthand notation. It's easier to memorize. So f prime g means this. G prime f means this. So f prime times g, 1 times x squared. G prime times f, 2x times x, and they add up to 3x squared. And this is the same as this one, as you can see this example works. Before we move on to examples of our own, I want you to do this at home. Now the question is, find the derivative both ways. What do I mean by both ways? And number one, the easy way is to distribute and use the power rule, finish the job. Number two, for practice, use the product rule. This is the first function, this is the second function, let's say f times g, and that is for the sake of practicing. As a warm-up example, and we are not going to simplify, I'm going to differentiate y equals x to the power of 4 minus 2x cubed minus 7 times 3x squared minus 5x. So I'm going to call the first one the f function, and the second one the g function. That means f of x, that means g of x. And I'm going to stick with the easy way out. By the way, I would always write the formula next to me from memory and follow that. Those of you who've learned this before, and you can say d dx of this expression, d dx of that expression, that's fine, but it can get very tedious and hard to follow. It's your choice. If you've learned it already, so be it. If you haven't, I'm going to write the formula, and I'm going to say I need f prime, which is 4x cubed minus 6x squared times g, which is simply the blue function, plus g prime, which is 6x minus 5 times f, the red function. And this is the only calculus step. Now you need a few more steps to finish this algebraically. I leave it for you to do so because this is just a warm-up example. If h of x is x e to the power of x, we want to find h prime and h double prime. First and foremost, we notice that we are multiplying two functions, so I'm going to put a raised dot in between. And I'm going to use the product rule. So I'm going to call this f times g, and I'm going to use the product rule on that. F prime is 1 times g, which is e to the power of x, plus g prime, the derivative of e to the power of x is itself, times f, which is x. I'm done with calculus. I'm going to factor the e to the power of x out. This gives me 1, this gives me x. Of course, 1 plus x, x plus 1. If I want to differentiate it again, now I'm going to go with the product rule again, and I'm going to call this the f function. E to the power of x is the f function. 1 plus x is the g function now. F prime is itself, e to the power of x, times g. 1 plus x or x plus 1 makes no difference. And then g prime, the derivative of the parentheses is simply 1. And times f, which is e to the power of x. If I take e to the power of x out, I have x plus 1 here. I have 1 here, and I get e to the power of x times x plus 2 as the final answer. Y equals x squared sine x. I put a raised dot in between, and I'm going to say f times g. The f function is simply x squared, and the g function is sine x. And again, I go back to the product rule, and I use that. So x squared, of course, using the power rule gives me 2x times g, which is simply sine x, plus g prime, the derivative of sine is cosine, times f, which is x squared. And basically we're done. 2x sine x. I put the x squared in front because I've seen students making a mistake thinking this is x cubed, which is not. Don't mix them up. Here's a warm-up example for the quotient rule, and I'm using the same f and g that we used for the product rule. The top is the f function, the bottom is the g function. And again, this is a shorthand notation I'm going to stick with. It goes a lot faster than if you have seen this before, slightly in a different format. So f prime, so we have y prime equals a huge fraction bar. F prime is 4x cubed minus 6x squared times g, the blue function, minus g prime 6x minus 5 times f, the red function, over g squared, just the blue function in the parentheses, and square it, and we're done with calculus. Now we have several steps of algebra to finish it. I'm going to leave it for you to do so. I can't emphasize this enough. So we want to differentiate y equals x squared minus 3x over x minus 1. And we are going to use the quotient rule. F prime, that means 2x minus 3, times g, that means x minus 1, minus g prime, that means 1, times f, that means x squared minus 3x, over g squared, that means x minus 1 quantity squared. Done with calculus. We are going to simplify by distributing here or foiling and distributing here. So what I want to quickly show you, the foiling, you should be able to do this fast. So this is obviously 2x squared. When you multiply this 2, you get negative 3x, and this 2, you get negative 2x. They add up to negative 5x. And then plus 3 minus x squared plus 3x. So that shouldn't be a big deal. Now let's combine what we can, and we notice 2x squared and minus x squared, they add up to x squared minus 5x and 3x, they add up to negative 2x. Now, anytime you have a fraction or a rational function, the question is it in lowest term? Am I done? So if you want to simplify this, you have to factor it. And the question is, can I factor it? Even if you can factor, and it doesn't have a factor of x minus 1, it can't simplify. But how do you know this is factorable or not? Recall, ax squared plus bx plus c equal to 0 is a quadratic formula. X equals minus b plus minus the square root of b squared minus 4ac over 2, all the solution to that, where b squared minus 4ac has a name, is called the discriminant. If it's positive, you have two real solutions, 0, 1, and if it's negative, you have no real solutions. So b squared minus 4ac is positive, you have two distinct real solutions. The solutions will be rational if the discriminant is a perfect square and irrational otherwise. B squared minus 4ac is 0, that means one real solution, rational, and if it's less than 0, no real solution, two complex solutions. So if b squared minus 4ac is a perfect square number, then we can factor ax squared plus bx plus c, and that's very interesting. Make sure you remember that. So all you have to do, calculate this b squared minus 4ac for this expression, which means a is 1, b is negative 2, c is 3. So b squared minus 4ac, that means negative 2 squared minus 4 times 1 times 3, ends up being negative 8. And not only it's not a perfect square, in fact, it's a negative number. If you were to set it equal to 0, actually, you would get to complex solutions to conjugate imaginaries. And so this can't be factored. That's how you know for sure. This was a piece of information from algebra. I hope everybody remembers that. All right, we're going to continue h of x is square root of x times e to the power of x. To differentiate this, first and foremost, square root of x, as you recall, is x to the power of 1/2. And we put it in that format so we can use the power rule. And I put a raised dot in between to remind everybody this is going to use the product rule. F, G. So we are going to follow that. F prime is half of x to the power of negative 1/2 using this, times g, that means simply e to the power of x, plus g prime, that e to the power of x, plus g prime, the derivative of e to the power of x is itself, times f, the first function. You can write that as square root of x or x to the power of 1/2. So what happens here, we are going to take this down, make it to the power of 1/2. Remember the negative exponential rules. In this case, we are using this one. So I'll put all the information for you here. Take it down, x to the power of 1/2, and bring it back to the format of square root of x, and this guy is square root of x also. Now, to combine them, especially for later usage when we need to set the derivative equal to 0 and otherwise, I'm going to show you how we move on. And again, please understand this is the only calculus step. Everything else is algebra. And so to combine these two, you may recognize that, well, the denominator is a 2 square root of x, and you can take the common denominator of 2 square root of x, which means the first one, everybody, is just this one, right? Take a look at this one. But the second one, you have to raise it by a factor of 2 square root of x over 2 square root of x. If you expand this, the product of these two, you get e to the power of x times, you have square root of x, 2, and square root of x. I hope you recognize it as 2x. And if I factor the e to the power of x out, I get 1 plus 2x over 2 square root of x as the final answer. This is one way to write it. The second way is to write it in this fashion, and notice that this is in common between the two. If you take this out as a common factor, this will result in 1, this will result in 2x. Please understand this format, I'm going to call it number 2, and this format, they are the same. Now, y equals e to the power of x over 1 plus x. We are going to differentiate this, and I'm going to erase everything first. And then I'm going to write f over g, which means I need to use the quotient rule. So f prime is e to the power of x times g, the denominator is 1 plus x, minus g prime, it's simply 1, times f, which is e to the power of x, and then over g, that means 1 plus x squared. So I'm done. I'm gonna simplify this, and please understand again that this is the only calculus step. So if I want to combine them, I'm going to distribute. I get e to the power of x, e to the power of x times x, minus e to the power of x, and these two cancel each other. I put the x in front of e to the power of x, and I'm done. X e to the power of x over 1 plus x quantity squared. Y equals 1 plus sine x over x plus cosine x requires the quotient rule as well. So f prime, 1 is 0, sine is cosine, g x plus cosine x, minus g prime 1 plus negative sine x. That means, because the derivative of cosine is negative sine x, that means 1 minus sine x. And then f 1 plus sine x. And the denominator is g, the same thing, x plus cosine x squared. Done with calculus. Let's finish using our algebraic techniques as well as trigonometry identities. So let's distribute. This is x cosine x. This is cosine squared. And this one a minus b, a plus b equals a squared minus b squared. So that means 1 minus sine squared. So this whole thing is 1 minus sine squared, and this is the distribution. Pythagorean identities in trigonometry, sine squared plus cosine squared equals 1. If you divide both sides by cosine squared, you get tan squared plus 1 equals secant squared. If you divide the first one, both sides by sine squared, you get 1 plus cotangent squared equals cosecant squared. You had seen this in trigonometry. If you haven't, now you have. And so if sine squared plus cosine squared is 1, then 1 minus sine squared must be cosine squared. It's important to know that if you know this, you can make up several formulas from that. For example, 1 minus sine squared equals cosine squared, or sine squared is 1 minus cosine squared, or sine x is plus minus the square root of 1 minus cosine squared. So it's just, different formats you can. So with that being the case, clearly, these two cancel each other, and you're done. The numerator is simply x cosine x. So the final answer is y prime is x cosine x over x plus cosine x quantity squared, and we are done. So it's very straightforward, everybody. And I hope it makes sense and everybody is okay following that. Now, in this case, the question is g of t equals t minus square root of t over t to the power of 1/3. Should I use the quotient rule? Now, can I use the quotient rule? Yes. Should I use it? No. Why not? I want to make sure we understand that, because if we don't see the easy way out, then the long way, the quotient rule probably won't do us any good. Understand that the denominator has one term. In this case, it's not a term because it's not a polynomial. Rather, one algebraic expression, you can make up two fractions. Meaning this is 1 and this is another one. You're going to take the square root of t and change it to t to the power of 1/2. Therefore, you can use the quotient rule from the exponential rules. This is 1. So this first one is t to the power of 1 minus 1/3, and the second one, t to the power of 1/2 minus 1/3. So this number, everybody, 1 minus 1/3 is 2/3. This number, everybody, 1/2 minus 1/3 is 1/6. And now we are going to use the power rule. Therefore, we are going to say g prime of t is 2/3 t to the power of 2/3 minus 1 minus 1/6 t to the power of 1/6 minus 1. This results in negative 1/3 this results in negative 5/6. Negative goes down, becomes positive in both cases. And we are looking at this concept, negative goes down, because the negative exponential rules. And the answer is 2 over 3 t to the power 1/3 minus 1 over 6 t to the power 5/6. And you're done. You don't have to write them as roots, because if you go back to this part, this was given as a exponential format, fractional format. However, this is just in case if anybody is interested to know this, and you don't have to change that. This is the cube root of t. This is the 6th root of t to the power 5, in case. Now, as far as sine and cosine are concerned, it takes a little bit of a work from trigonometry to prove them. The rest of them are easy. For example, we are claiming d dx of tan x is secant squared x. That means the derivative of tangent is secant squared. And I'm going to show you how easy it is to prove that. We know tan x is sine x over cosine x. And how do we know that? Tan x is sine x over cosine x. This is from trigonometry. Also 1 over cotangent x. Cotangent x is cosine x over sine x, or 1 over tan x. Secant x is 1 over cosine x, and cosecant x is 1 over sine x. So I'm going to write f over g, and I'm going to use the quotient rule. So f prime g minus g prime f over g squared. Again, I can't emphasize this enough. The way I do the work, I write what I need, the formula from the memory. I have to memorize it. And then I apply that. So f prime, the derivative of sine x, is cosine x times g cosine x minus g prime minus the derivative of cosine is negative sine times f sine x. The bottom is g squared cosine x squared. That means cosine squared x. And again, I'm done with calculus. So this is cosine squared. This is plus sine squared. And as we discussed in the previous page, the sum of the numerator, they give us 1. So 1 over cosine squared x. We know secant is 1 over cosine. So 1 over cosine squared must be secant squared x. Therefore, d dx of tan x is secant squared x. We proved that. d dx of secant x is secant x tan x. We want to prove that. To prove that, well, y equals secant x is 1 over cosine, and we are going to use the quotient rule on this one now, where the f function is just number 1 and the g function is cosine. So f prime g, that means the derivative of the numerator, any number is 0, times cosine x, minus g prime f. G prime, the derivative of cosine, negative sine, times f, the f function is just number 1, over g squared cosine squared x. Again, we are done with calculus, and we know this goes to 0, so we have negative times negative, positive sine x in the numerator. We cut this into 2 fractions, 1 over cosine and sine over cosine. Please understand, if you multiply these two, you get sine. If you multiply these two, you get cosine. But what is 1 over cosine? Secant x. What is sine over cosine? Tan x. And therefore, we prove d dx of secant x is secant x tan x. Find an equation of a tangent line to the graph of the function y equals x over 2x minus 7 at 3 comma negative 3. To find the equation of any line, we need a pair. As long as they give us x, we can plug it in and we can find the y coordinate. The pair is given. We don't have to plug in. Also, we need the slope. When the slope is not given, as it is the case here, we differentiate the function and then we plug in the x coordinate to find that. In some cases, we may have to plug in x and y. So in this case, we are going to say f over g, and we are going to use the quotient rule again. F prime 1 times g 2x minus 7 minus g prime 2 times f, which is x, over g 2x minus 7 squared. So put it in a parentheses, squared. And believe it or not, this is the only calculus step. Let me box that, class. I want to make a point here. This is really important to understand. This is it. You're done with calculus. This is the only calculus step. Everything else is algebra. So the first thing is to simplify the numerator. 2x minus 7 minus 2x. Clearly, 2x and minus 2x cancel each other. And y prime is simply minus 7 over 2x minus 7 squared. So that's not the slope. So what is the slope? Plug in 3. That's how you find the slope, everybody. Replace the x with 3. So what happens when you do that? This is 6. This is minus 7. So inside the parentheses, the whole thing goes to negative 1. Square it, you get positive 1. So the answer is minus 7. So it's pretty straightforward. Y minus y1 equals m times x minus x sub 1. Which means y minus negative 3. That means y plus 3 equals m negative 7, x minus 3. And you distribute on the right side to get minus 7x plus 21. You move the 3, make it negative 3. They add up to y equals minus 7x plus 18, and this pair belongs to the original function, also belongs to the tangent line. Therefore, you can check if you plug in 3, do you get negative 3? Yes. When you check, it doesn't say anything about what happened here except this part. This part has been done correct. That's all. That's what it tells us. So don't mix them up, which is important to know. So it's good. It's a good idea to practice, to show work and check always. Always check. It's the beauty of math. You can check your work. Okay, everyone. You can check your work, and that's really important. Now, what about this case and what's going on here? Class, on purpose, I'm picking up a variable that is not used normally. Normally, we use x, sometimes t, but anything else doesn't matter. Understand the concept. I'm going to call it f over g. And again, I'm going to go with the quotient rule. So the derivative of the numerator, so remember, m is the independent variable. And so f prime, the derivative of 9m is 9 minus 7 is 0. So the top gives you 9. Times g, which is 5m plus 4. And then g prime, the derivative of the bottom is 5 times f 9m minus 7 over g 5m plus 4 squared, 5m plus 4 squared. Done with calculus? Okay, done with calculus. And all we have to do, simplify using our algebraic techniques, everybody. Simplify using our algebraic techniques. So that means we're going to distribute. We get 45m plus 36 minus 45m plus 35 These two cancel each other and they add up to 71. So h prime of m is 71 over 5m plus 4 quantity squared, and we are done. Find an equation of a tangent line to the graph of the function y equals e to the power of x cosine x at 0, 1. And of course, we need two things. We need a pair is given. We need the slope. It's not given. We are going to differentiate by putting a raised dot here. And use the product rule on that. So f prime is e to the power of x times cosine x, the g function, plus g prime, the derivative of cosine again is negative sine, times f e to the power of x. This is the only calculus step, everybody. So that's important to know, that there's really not much you have to do as far as calculus. So factor out the e to the power of x and you get cosine x here minus sine x. And this is the derivative function. Now we are going to plug in. When we plug in, what happens? Let's just make sure we understand this. We get e to the power of 0, cosine of 0, minus sine of 0, which is e to the power of 0 is 1, cosine of 0 is 1, sine of 0 is 0, and that gives us 1. Now, we can use y minus y1 equals m times x minus x of 1, but we don't have to. The reason we don't have to, because this is the y-intercept. Let me use a different color. Y-intercept, therefore b is given as 1. We are going to use y equals mx plus b. M is 1, so is b. Normally they are not the same. It just happened to be the case. Okay, class, we don't want to be under the assumption that is always the case. It's not. It just happened to be the case here. Y equals 1 minus secant x over tan x, and we want to differentiate that. We notice we have to use the quotient rule. 1 minus secant x is f of x, tan x is g of x. So we are going to go with f prime 1 gives you 0 minus secant gives you secant x tan x. So minus secant x tan x. This negative sign is because this one has a negative sign times g, which is simply tan x, minus g prime, the derivative of tan x is secant squared, times f, the numerator is 1 minus secant x, and finally the bottom is g squared. Tan x to the second power means tan squared x. And again, done with calculus. So we have here negative secant x tan squared. Here is negative secant squared x. Here is plus secant cubed. All of them have a secant x is in common. So if we take out the secant x, this gives you negative tan squared. This gives you negative secant. This gives you positive secant squared. So we are factoring. Reminding you of a Pythagorean identity, 1 plus tan squared is secant squared, everybody. Therefore, if I move the tan squared to the other side, then secant squared minus tan squared can be replaced by 1. The two of them add up to 1. The two of them will be replaced by 1. And we are going to say y prime is secant x times 1 minus secant x over tan squared x as the final answer.